What if the biggest threat to our oceans and to our own health was completely invisible? Every year, tons of toxic heavy metals from industry, mining, and burning fossil fuels seem to disappear into the sea. But they don't actually vanish. They begin a hidden journey, a journey that can end right here on our dinner plates. So how does a pollutant released miles away become a secret ingredient in the fish we eat? Today, we're going to trace the invisible path of these metals as they're eaten, stored, and passed up the marine food chain, becoming more concentrated and more dangerous every step of the way. It all begins with how these metals get into the water in the first place. Heavy metals like mercury, lead, and cadmium come from a mix of sources. Some are natural, like volcanic eruptions and the weathering of rocks. But human activities are the biggest contributors by far. Think of industrial factories, mining operations, and even the burning of fossil fuels. They all release these metals, which eventually find their way into our rivers and oceans. Once they're in the water, these metals don't just float away harmlessly. They're persistent, meaning they don't break down easily. They dissolve or cling to tiny particles sinking into the sediment. The ocean essentially becomes a massive storage tank for these invisible contaminants, setting the stage for a toxic chain reaction. Now, picture the very bottom of the aquatic food chain, tiny organisms like algae and plankton. These little life forms are the entry point. They absorb the dissolved metals directly from the water as they live and breathe. This is the start of a process called bioaccumulation. Bioaccumulation is the gradual buildup of a substance inside a single organism. It's pretty simple. The organism takes in the metal faster than its body can get rid of it. Fish also absorb these metals directly through their gills and skin. Over time, the metals get stored in the animal's tissues, sometimes in the liver and kidneys, but for certain metals, even in the muscle tissue that we eat. So, a single small fish, over its lifetime, can build up a concentration of heavy metals much higher than what's in the water it calls home. One contaminated fish might not seem like a big deal, but it's just the beginning. That small fish is going to be eaten by a bigger fish, and this is where biomagnification comes in. Biomagnification is how the concentration of a toxin gets more intense as it travels up the food chain. When a predator fish eats thousands of smaller contaminated fish, it doesn't just get their energy, it also absorbs and holds onto almost all the heavy metals they contained. While the energy gets used, the metals just keep building up. This effect is especially dramatic with mercury. Bacteria in the water can convert mercury into a highly toxic form called methylmercury. This stuff is absorbed very easily by organisms but removed very slowly, which makes it particularly dangerous. With each step up the food chain, from plankton to small fish to larger fish, the concentration of methylmercury multiplies. This is exactly why long-lived predatory fish at the top of the food chain, like sharks, swordfish, and some larger types of tuna, have the highest levels of mercury. They've spent years eating other contaminated fish, concentrating all those toxins in their own bodies. But the food chain doesn't stop with a shark or a tuna. The final link is often us. When we eat these large predatory fish, we are the ones who get that highly concentrated dose of heavy metals. Long-term exposure to metals like mercury, lead, and cadmium can have serious health consequences. Mercury is a powerful neurotoxin that can damage the central nervous system, and it's especially dangerous for developing fetuses and young children. Other metals can cause issues like kidney damage and cardiovascular problems. The specific risk depends on the metal, how much is consumed, and how often you eat that type of fish. So, the journey is complete, from an invisible pollutant in the water to a concentrated toxin on our plate. It starts with pollution, builds up in the smallest organisms through bioaccumulation, and then gets passed up the food chain, multiplying in strength through biomagnification. Knowing this isn't about being afraid of seafood. Fish is an amazing source of protein and healthy fats. This is about empowerment. When you understand how this invisible process works, you can make more informed choices about the types of fish you eat and how often. If this explanation was helpful, be sure to subscribe for more deep dives into the science of our world. We'd love to hear from you in the comments. Does this change how you think about the seafood you eat? Thanks for watching.